Hey guys, it's your favorite TA here. This week we are doing experiment number 3, which is determining Avogadro's number by doing electrolysis. If you want to learn more about what that is and what we're doing, then you should read the theory section of your lab manual. Hopefully all of you who watched the pre-lab video for last week figured out just how important and beneficial it is to watch the pre-lab videos. This is why we stress that you guys watch them so much, and you most definitely should try to watch them every week before you come in and do an experiment, so that hopefully things go a little bit smoother for you when you guys are doing the experiments yourselves. Okay. This week's experiment is not as strenuous or tedious as last week's, but for many of you, I think the main issue will be learning how to navigate and use the LabQuest. And so I'll go ahead and show you. This is the LabQuest, okay? And I think it's safe to say that we've all had our fair share of frustrations with technology before. So if you get easily frustrated, or if you've had a bad day before coming to lab, you might want to ask your lab partner to attempt to use the LabQuest, because they are still expensive pieces of equipment. So I'm going to move on from that. So let's go through the procedure for this week's experiment, and I'll teach you guys how to use the LabQuest, only what we need to actually do this experiment, and then other things we'll talk about when we need to use them for other experiments. So step number 1 tells you to use steel wool to clean a strip of copper and zinc. Those are the two metals that we're working with. So this is my zinc and this is my copper. The reason we say to clean it is because we do try to reuse these strips of metal, either between experiments or labs that we have every week, or even between years. So sometimes you might pick up your strip and it kind of looks like this, versus having a fairly brand new strip. You can tell the difference for sure. So make sure you get some steel wool, or we might even have some steel sponge, and do your best to kind of clean off all of the whatever that is on the outside of the strip. Okay. Step 2 tells you to use a balance to measure the mass of the copper strip and record that mass in your data table. The data table is on your data sheet. And an important note about us measuring the balance of the copper strip throughout this lab would be to make sure you are using the same balance every time you weigh your copper strip. Not all of the balances are exactly the same or calibrated exactly the same. So it's super important that you go to the same balance every time you're weighing your masses, so that you get more accurate results. Step 3 tells you to fill a 250 milliliter beaker with some 1 molar sulfuric acid solution. You'll notice that you do have a danger in all caps warning in your procedure. It is sulfuric acid. We do want you guys to be careful with it, and make sure you are wearing your safety glasses this week, okay? You should be wearing them every week, but So you should already have a 250 ml beaker at your station, just like y'all had everything you needed last week at your station. And you should put about 100 to 150 mils of acid in your beaker. We only need enough to submerge the copper and zinc strips into, and it doesn't have to be perfect. So you don't need a graduated cylinder. Just kind of eyeball it using the lines that we have on the beaker. Step 4 tells you to gently turn the dial of the constant current system counterclockwise to make sure it's in the minimum current position. Up until this point, you guys haven't used any of our veneer equipment either. So usually that should be at your station, and it will most likely be in a box. So this is the box for your constant current system. And we will actually have 2 things inside. You will have a constant current box, which has 3 different attachments. It has a red lead, a black lead, and it also has an attachment for your LabQuest. And then you'll also have your power supply. So of course this goes into the outlet, and this will plug into your constant current box, okay? But the minimum position on the box will be exactly where I have it. There's all these wires everywhere, sorry. But see how, you know, when you turn the dial to the thicker portion, that means you're getting more current, and so going to the thinner portion means you have less current. So where I have it right now is the minimum current position. Okay. So step 5 tells you to clip zinc to the black lead and copper to the red lead. And it also tells you not to put the leads in the beaker until later on in step 8. So it also tells you to refer to figure 3.1, which is just below step 5, and you'll notice that the leads happen to be sitting perfectly upright in that beaker of acid solution, and there's nothing holding them. I don't know what kind of magic that is, but we can't do that in the lab. So you guys could hold them, but we were trying to help you guys out and not have to do that for several minutes at a time. It's difficult to keep them even and make sure you're not wavering any. So what we did is we're going to give you guys a ring stand and an electrode support. And so all you're going to have to do, let's see. So this is my zinc strip attached to the black lead and my copper strip attached to the red. And you can just take these grooves that are in the electrode support here and here, and you can just kind of string through the wires. Let's see. And it will hold your leads for you, okay? And there's multiple different grooves in here, so you can position them in the beaker to where, you know, we don't want the leads or strips to touch each other. We don't want them to touch the glass. And we most definitely don't want the leads to be submerged in the acid solution. So please be extra careful about that. We don't want this part of the clip to touch the acid, okay? And these clips are actually really easy to use. They're alligator clips, so you just squeeze and it opens it up, and so you can take them in and out pretty easily, okay? So you'll just string these through the right distance apart that you need for them to fit in the beaker. Okay. So step 6 tells you to plug the constant current into an outlet and connect it to channel 1 of the LabQuest. So all we have to do to plug in the constant current, we're going to plug this into the outlet at your station, which would be near the top. And then you'll plug in this end. You'll see we have a plug-in spot on this constant current box, and that will give us power, and you'll know because you'll get a red light on this end, okay? And then it tells you to connect this constant current box to your LabQuest. Well, that was this plug here. And so channel 1, there's going to be 3 channels on the side of your LabQuest, and they're all labeled. So this is channel 1, so I'm just going to plug this in, and your your LabQuest, sorry, will recognize the constant current box. So now we're getting into actually using the LabQuest. Step 7 tells you to turn on the LabQuest and choose new from the file menu. I do recommend choosing new just because if you're not the first lab of the week, there may be a lab prior to yours that has all of their stuff left in there. They may not have cleared it out like they're supposed to. And so choosing new just makes sure that you are putting in the right settings and that it's only your stuff in the LabQuest while you're using it. So the LabQuest has an on button on the top. It's going to be right here, and mine should already be on actually. And so you'll see that there's actually a stylus for you guys to use to make it easier to use the LabQuest. And at the top, it's going to say File, and then New should be the first thing in the drop-down menu. Okay, and you do notice that it's saying that we are measuring current in channel 1 of the LabQuest, and it's showing it in amps, okay? And then it tells you to change the data collection rate to 0.2 samples per second and the duration to 180 seconds. So if you can see on this side, we are in time-based mode, and that's exactly what we want, so don't mess with that. But then we've got rate at 0.5 samples per second, and it says duration at 1800. We definitely don't want all of these trials to run 1800 seconds. So all I'm going to do is I'm going to click where those are, and then I can change things. So I'm going to click in this white box to change my rate. So when I do that, I got it all tangled up. Okay, there we go. So I'm going to click the white box, change it to 0.2, and then I'm going to click done in the corner, and now it's changed my rate. The interval will change for you, so don't change the interval, but then you're going to click in the white box for duration, and you're going to change that 1800 to 180, and then you're going to click done in the corner. Okay, so now my rate is saying 0.2 and my duration says 180, and then I can just come to the corner and click OK. And that should change all of my settings, and you'll see that show up here where we saw it originally, 0.2 and 180. Okay, so now that we've done that, it tells you to put your electrodes into the sulfuric acid solution that's in your beaker, and it says to make sure that they are immersed to equal depths and as far apart as possible. Again, you don't want them touching each other, you don't want them touching the beaker, and we don't want those clamps in the acid. So just do your best, and I know that the strips may be different lengths, so just do your best to get the bottom of them even. Step 9 tells you to start data collection and that it will last for 3 minutes. So for those of you who didn't do the math, the 180 seconds that we put in is the 3 minutes that we're collecting for. And the thing about using the LabQuest in time-based mode, when you click start, which will be this play button here, okay, it will take you to the graph. The LabQuest will time it for you. So it will run for 180 seconds and then it will stop on its own. So you guys don't have to use your cell phones or anything to keep track of those 3 minutes. The LabQuest will do that on its own and the graph will stop running and you'll be able to tell. And there will be a stop button at the bottom, but you shouldn't have to push it. Again, it will run out that 180 seconds and then it will be done. And so you'll see a note by step 9 that says to be ready to turn off or unplug the power as soon as data collection stops. So you do need to be watching that graph on the LabQuest, and as soon as it stops, you're going to want to unplug the constant current box. Well, instead of unplugging it from the actual outlet, we can just unplug the box itself. So you can just do this and that will take care of the power. Okay, my red light went off. And we do that for a few different reasons. So for one thing, you don't want to touch it when there's current running through it. For another, we are measuring the mass of copper every time. And so if you let current run through that copper strip, the reaction is still happening even though you're not collecting data on the LabQuest. The LabQuest doesn't decide if the reaction is still running, it's just collecting data on the reaction for whatever time you put in. So if you leave the current running even after your LabQuest has run the 3 minutes, then the copper is still losing more mass. So you need to be able to turn off that power as soon as it stops so that you don't lose more mass on the copper than you should. The other reason has to do with us using the metal strips because it will wear away at the zinc strip. And so you'll see this is one where the strip has been overused, and you guys won't get one like this because I'll make sure that there aren't any in there. But it is super thin, guys. Like this, it should not be like this. A new strip is fairly bendable, but it takes a little bit more effort, and it makes more of a curve instead of a sharp bend. And so what I don't want to happen while you guys are doing this experiment is for your lead to be in the acid solution, and if you leave the current on while your zinc strip is still in there, you know, it could fall apart. That has happened to people before, and they've got to get a new strip, and it's just a whole situation. And then also, you know, we lose the strips a lot earlier than we have to. And so we don't want to do that. So please help us prolong the life of the zinc strips and make sure you are turning off that power. And that's the other thing too that we have done to help you guys. So you can leave your zinc strip in the solution. You don't have to take it out every time you take the copper strip out, because it's okay to leave it in the solution as long as you have unplugged the constant current box's power. Okay, so you don't have to take that zinc strip out. You can leave it so that all you're messing with is the red lead with the copper strip. Okay, just don't let that power be connected to the current when you're not collecting data. Okay, that was like a whole spill. So now we're on step 10. So it tells you to check the readings of current coming from the meter and adjust the settings to be a current between 0.2 and 0.4 amps. So when it's saying current from the meter, so there are different screens on the LabQuest. So if you've ever used Microsoft Word, you know at the top you've got home, view, insert, things like that. And so we have different buttons at the top of our LabQuest. Well, the one that I'm on currently will always be the one most to the left, and it's called the meter screen. And it's actually got a little figure here that looks kind of like the speedometer in your car, okay? And so this is what it's telling me what my current is. Well, I have my constant current box turned off, so it's not really measuring any current. But once I put my leads into the acid solution, I can turn the knob on my constant current box and get a different amps. So you guys just need to gently and slowly kind of turn until this number in this red box changes to somewhere between 0.2 and 0.4. It doesn't have to be 0.2 exactly or 0.4 exactly. It can be 0.37 or 0.25 or 0.31. It doesn't matter. It just needs to be in that range, okay? And so you're going to do that just by turning this knob once your leads are in solution, okay? Step 11 tells you that when data collection is complete, don't forget to turn off and unplug the power. And then you're going to remove your copper strip from the sulfuric acid. Again, you can leave the zinc one in the solution once you've turned off the power. And then you're going to rinse that copper strip with distilled water. Those are the squirt bottles that you guys have at your station. And then you're going to pat it dry with a paper towel. And of course, we do that because we don't want extra weight from the distilled water on the balance. Okay. And then step 12 tells you to measure and record the mass of that copper electrode to make sure, again, that you go back to the same balance used to get the initial mass. Okay. And the other thing that I will say here is that you'll notice we're going to do these steps 3 times. We're going to have 3 trials where we run this 3-minute data collection, right? And so on your data table for each trial, you're going to have an initial mass of the electrode and a final mass. Well, you'll only need to actually measure an initial mass per se for your first trial, okay? Because when you're moving between trials, so for example, the final mass for your trial 1 should be your initial mass for trial 2, okay? Because you didn't do anything with it from the time that you waited to the time that you're going to put it in for trial 2. Okay, unless you're using a new strip, but you shouldn't have to. You should be using the same copper strip for all 3 trials. Okay, and so the same thing will happen between trial 2 and trial 3. The final mass of the copper strip for trial 2 should be the same mass that you use for initial mass on trial 3. Okay, so you can just bring those numbers up to the next trial. All right, so step 13 tells you to determine the average current applied during the experiment. So when you are looking here, this will be your graph screen, okay? And so when you're collecting data and you click the play button from the meter screen, it should automatically go to the graph screen. And so it tells you to choose stats from the Analyze menu. So here's Analyze. So we'd click on that, and then I can't read from there. And then we would click Stats, and then you'll see the box pop up that says Current. So I'm just gonna check that box. And now I have a bunch of things that have popped up over here. And of course, I don't have a graph because I didn't actually run anything, and I don't have my leads in solution, but it tells me minimum, maximum, and then mean. And so the part B tells you to record the mean or average current in your data table. So where you see mean, which is the third one down, whatever number appears there is what you're going to put for average current in your data table for that trial. Okay, and then step 14 tells you to clean the electrodes. Well, they should already be clean. And then to measure and record the mass of the copper electrode in preparation for a second run. Well, we already talked about that, right? The final mass from the trial you just did should be the same as the initial mass for the trial you're about to do. And then it tells you so you're going to reconnect your copper strip and then repeat steps 8 through 13, 2 more times to where you've got a second trial and a third trial. Okay, and then the last step tells you that when all of them are complete, so we're going to clean the leads with distilled water. So you're going to rinse off the copper strip and the zinc strip, kind of rinse off the alligator clips, because even this one has a bit of some stuff on it and it shouldn't. So just in case you get anything on it, please just rinse them off for us, and then dry them off with a paper towel. Put the constant current box and its leads and the power supply back in this constant current system box at your station for the next lab to use. You can pour the sulfuric acid that is in your beaker down the sink. It's actually copper sulfate now, which is just a salt, so it's safe to pour it down the sink. And then you're going to put your strips that you take out of your leads. We're going to have some paper towels underneath the front hood, one for copper strips and one for zinc strips, and you're going to put it there so that we can kind of inspect them and make sure that they're still good to use for the next labs that come in after you guys. Okay, so the only other thing to talk about is your data sheet. And so the first 3 things in your data table for every trial, we've already talked about those from the experiment: the initial mass, the final mass, and the average current. You know how to get all those. And then time of current application, well, we ran all of them for 3 minutes. We put in 180 seconds. So your time of current application for all 3 trials should be 180 seconds. Okay, and then for data analysis, so you've got 5 different types of calculations you're going to do. They're not difficult. You even get the formula at the end of all the questions. So, for instance, number 1 tells you to calculate total charge. It gives you the unit, right? So don't forget to put your units. So all of your answers for number 1 should have coulombs as the unit at the end. And it tells you that the way to calculate that is to multiply your average current, which comes from your data table, by time of application, which was 180 seconds for all 3. And so when you're doing all 5 of these data analysis questions, you need to have work for all 3 trials. Don't do just your first trial for all of these and then consider it done. You should have 3 answers under every single question, okay? And then number 2, you're going to notice that all of these questions build on each other, so you'll end up needing your previous answer to do the next question, okay? So at the end, it tells you in order to calculate the number of electrons, you're going to take total charge, which is what you calculated in number 1, and then divide it by the charge of an electron. Well, it gives you what the charge of an electron is, 1.602 times 10 to the negative 19th coulombs, right? So then just show work for all 3 trials on that. So then you just keep going, you'll do 3 and 4, and then number 5, you usually get a good amount of questions on because it doesn't just give you the formula outright, but you guys shouldn't have a hard time doing this one. It's actually a lot easier than you think, especially if you've done your pre-lab, and hopefully you have before you come to lab. It's saying that you want to calculate the number of atoms per mole. Okay, so you're going to take, in number 4, you calculated copper atoms per gram, and we want atoms per mole. And so essentially you're not messing with the atoms at all. All you really need to do is take, whatever step you need to cancel out grams and get moles. Okay, so think about that. And if you need the molar mass from the periodic table for copper, we actually have periodic table tiles on the wall now that have the masses that you need. So if you don't know that, don't panic. They're on the walls, or you can ask your instructor or TA. Okay. And then the second part of that question tells you to compare the values to Avogadro's number and discuss how those values relate to the true value. So we know what Avogadro's number is, or hopefully you do. And so it's not a very difficult question. You're just going to talk about, is your value, is it bigger than Avogadro's? Is it smaller than Avogadro's? Is it really close? Is it really far? Hopefully you get some numbers that are really close to Avogadro's number from this if you do things, if they go well. But if you don't, so for instance, sometimes people get 2 of their trials, they're really close to Avogadro's, and then 1, it's nothing like Avogadro's number. And so, but maybe they noticed they did something a little bit differently, or maybe they messed up somewhere along the way. Maybe talk about that when you kind of compare that trial's number. So say your trial 2 is really, really low compared to Avogadro's number, but you messed up somewhere. Well, then maybe kind of make a note and say, this one is a lot smaller than Avogadro's, but we kind of made an error, and maybe if we hadn't, it would be close to Avogadro's, just like our other 2 trials were. Okay. So this one is not that bad. I don't think it will take you guys too long. Hopefully you guys watching this will help. And I think I've covered everything. So I will see you guys, some of you, later in the week. And I hope you'll have a good week.